the series in parallel circuits. Okay, so first we're gonna solve for RT, which is okay. So we see that these two right here are in series circuit. So using Kirchhoff's law, we could add these two together to make it like one circuit, right? So just these, add these together. We have 19 plus 97. 16. Now, if we sketch this circuit out again, it'll look like this. Right? Because we condensed it, because these two are in series, and now we do parallel here, right? So then we know that 1 RT is equal to 1 over 83 ohms plus 1 over 116. If we just do 1 divided by 83 and 1 divided by 116, add those together, and then just do whatever it is you get, just do 1 divided by that number. Right, so 1 divided by, let's say, 0.0. And that will be your total resistance. RT equals 48.3819. We have total resistance, and then using Ohm's law, we have the total voltage right here. Ohm's law is if we want to solve for current, IT is equal to VT over RT. So we just plug in. You know, our total voltage is 12 volts. And then our total resistance is 3.9. Plug this into your calculator, and you get 0.248 amps. Okay. Now we're looking for the power to this one right here. Okay. First of all, we know that all of this here so we know that using Kirchhoff's law and Ohm's law, we know that the voltage here is equal to the voltage in these two because it's parallel circuit. But there will be voltage drop between these two. Okay. But we do know that all adds up to 12 volts, and it all adds up to 0.248 amps. And okay. So first, we have the total. We know how much volts is going to be here because again, it's parallel circuits, so it's going to be 12 volts. So using that, we could find I1. So an I1 is equal to V1 over R1. In this case, we know that it's 12 volts because it's in here, it's parallel. 12 volts, divide that by your R1, and we get, what is that? 12 divided by 83, around 0.1400. Oh, excuse me, rounded. So that's our amps for I1. And we know our total voltage. Okay, look, in a parallel circuit, current is added, right? So we know that this plus this will equal our total. So we have one part of it, which is 0.145, and then we're missing this. And we know that in a series circuit, current is constant. So the current going through this will be the same as going through this. So we know our total. We just do our total minus our I1. It will just give us 0.103 amps. Now, if we want to find the voltage drop for R2, which we need for power, we could just do V2 is equal to R2 times I2, which equals 19 ohms times 0.103 amps. You get 1.957. And then using power rule, you know that voltage times I. So we have our V2, and we have our I2. should equal roughly 2 watts.